Supreetha, welcome to my math class. So in the previous video lecture on limits, we studied about what is a limit, yes, the concept of limit, and then we studied something about a left hand limit and right hand limit. What happens when they are equal? We say that the limit exists, right? And then we studied algebra on limits, yes, and then we solved some problems. Okay, so in this video lecture, let us study something about sandwich theorem. Yes, what does the sandwich theorem states? Sandwich theorem. Okay, sandwich theorem states that let f, g, h be real functions such that f of x is less than or equal to g of x less than or equal to h of x. So for this, let me take a graph. Okay, let me take x and y axis. Yes, so they are saying we have g of x, that is between f of x and h of x, right? So we'd get f of x. Yes, next let me take g of x. Okay, and then I would get h of x. This is what the equality means, right? So yes, they are saying f of x is less than or equal to g of x less than or equal to h of x, right? For all x in the common domain of definition. What do you mean by this common domain? What do you mean by a domain? So if you have a function f of x which is equal to say a, okay, so this x is called as domain, right? So they are saying that this x, the input, is common for all these functions f, g and h. Now for some real number a, if limit x tending to a, f of x is equal to L, that is a limit. This is equal to limit x tending to a, h of x, then limit x tending to a, g of x would be equal to L. Okay, so this is what sandwich theorem states. Okay, let me take that this point is a and the limit at this point is L. Okay, this is f of x. Yes, this is g of x, that is sandwiched between f of x and h of x, right? So let us start with the proof now. So yes, sandwich theorem has a geometric proof. What does that mean? So basically it involves trigonometric functions, okay, that is cos x. So we just have to prove that cos x less than sin x divided by x is less than 1 in the region, okay, for 0 less than mod x less than pi by 2. So how do we start the proof? Let me take x and y axis, okay. So yes, let me take x and y axis. Let me take a circle, okay. So yes, let me take x, y, okay, and then a circle. So observe the inequality that is given, okay, that is 0 less than mod x less than pi by 2. Right. Now, let me take sin x. Yes. Replace x with minus x. What would I get? I would get sine of minus x. Sin x is an odd function. So I would get minus sin x. Okay. What is cos x? What is cos of minus x? Cos is an even function. So I would get cos x itself. Yes. So here, let me replace x with minus x. What would I get? That is cos x. Yes, this is less than. I would get sine of minus x, which is minus sin x. Yes, minus sin x divided by minus x. This is less than. There is no x here, so I would just write it as 1. So can I write it as cos x less than sin x divided by x less than 1? Yes. So can we say for any value of x, so even if x is negative, we would get the same thing. So I'll just write it as, I'll write the inequality as 0 less than x less than pi by 2. So what do you mean by this? 0 less than x less than pi by 2. This is this part of the circle, yes, on the x and y plane. So it ranges from 0 to pi by 2, right? This is our pi by 2. Yes. So in this region, let me take a point and name it as, say, C. Okay. Yes. Now let me join these two. Okay. So I'm joining this. Now what is this point? Let me name that as A. Okay. So let me draw a tangent at A. Yes. Let me join this. Okay. Now let me join this to the x-axis and name that as D. Okay, this is O, origin, and let me name this as B. So now can I say CD and AB are perpendicular to OA? Yes. Okay. Now, okay. So yes, for the inequality 0 less than x less than pi, so this part of the circle on the x and y axis, yes, we marked the point C. Okay. We joined it to the origin and then we took a tangent from A. Okay. And then we joined C to the x-axis. Yes. Now you see this area of the triangle ODC. Yes. Or let me join these both C and A. Okay. So now the area of, if I join this OCA, yes, this area, okay, let me draw that for you. It would be clearer. Okay. So yes, O is looking something like this. Yes, O, C, A. Yes. And something over here, you have a part of a circle that is joining CA, right? Yes. So this arc, yes, we have an arc over here, OCA. So the area of this triangle is less than this. Yes, agree? And the area of this sector OCA is less than the area of the triangle OBA? Yes? Let me write that down. Okay? Yes. So what did I say? Area of OAC is less than area of the sector. Yes, OAC. This is less than the area of the triangle OBA. Right. So at O, let me take an angle, say X. Okay. Now, what is the area? What is the formula for area of a triangle? Yes, can you recall what is the formula for area of a triangle? Isn't it half base into height? Yes, so let me do that over here. So let me take the triangle OAC. We have a line over here that is D, right? Yes. So area of the triangle OAC is half. What is the base? Base is OA, right? Into, what is the height? Height is CD. Agree? Because, okay, CD is perpendicular to OA, right? CD. So now this is less than, what is the area of a sector? What is the formula for area of the sector? Yes, the area of the sector, the formula for this is equal to, yes, pi r square into theta divided by, if it is in degree, you can write 360. Since it is in radians, let me write it as 2 pi. Okay, so 2 pi is 360 degree. Agree? In radians. So let me write that over here. So I would get pi times, what is r? What is the radius of the circle? Can I, okay, that is OA, right? So r square they are saying. What is the angle? The angle that we have taken is x, yes, divided by 2 pi. Yes, this is less than area of the triangle OBA. Yes, this triangle OBA. Now what is the base of triangle OBA? Base is OA. Yes, OA into, what is the height? OBA, AB, right? So you see, OA is present in all the terms. So let me cancel that out. See, we have OA here, OA, OA, right? Yes. And I can cancel even 2. Yes. Here pi goes away. Okay. So I would get here CD less than OA into X. This is less than AB. Now, let me take the triangle. Yes. From the triangle OCD. OC and D. You see the triangle OCD. I have written it over here. Okay. This is a right angle triangle. Agree? So let me find sin x for that. Yes. Let me draw the right angle triangle. Okay. So this is how it looked like. O, C and D. Yes. Let me check. Yes. O, C, D. Yes. So here I would get the angle x. So what is sine x here? What is the formula for sine x? Opposite by hypotenuse? Yes. Which is the opposite side over here? That is CD. Yes. This is the opposite, hypotenuse and adjacent, right? So that would be CD divided by OC. Now what is CD from here? That is OC into sine x. Okay, this is equal to CD. Now let me take the triangle. Yes, again the right angled triangle OAB. Okay, you see OAB. So at A we took a tangent, right? So let me find out tan theta. Let me draw that OAB. Yes, OA and B, and the angle is at O, right? OAB. Now what is the formula for tan x? What is the formula for tan x? OAB. Yes. So tan x is equal to opposite by adjacent. Yes. So tan x is opposite by adjacent. Which is the opposite side over here? Opposite is this same, right? Opposite, hypotenuse and adjacent. So what would I get? I would get opposite is AB. Yes. Divided by adjacent, that is OA. Now what is AB? AB is equal to tan x. Yes. Now let me write down the last step that we got here. That is CD less than OAX. Okay. CD less than OA into X. This is less than what? AB. Right? So we have a value for CD and AB. Right? Let me substitute that. Yes, what is CD? CD is OC into sin X. This is less than OA into X less than what is AB? Tan X. Right? So now you see we have OA over here. Yes, we missed the OA over here, right? We had it in the denominator. Okay, so here also we have OA. Okay, let me get back to the main graph. Okay, so you see OA is the radius of this circle. Agree? OC is also a radius of this circle. Yes. So the radiuses of a circle are always equal. Agree? You cannot have two radiuses for a circle. Right? So can I replace OC with OA? Yes. Remember that OC is equal to OA because they are radiuses of a circle. Okay. So let me replace OC with OA. Yes. Sin x less than x less than tan x. Yes. Into OA. Okay. So here also we had an OA. All the OA's gets cancelled. Yes. So what do you get? You get sin x less than x less than tan x. Right? Let me write that down. Sin x less than x less than tan x. Right? So yes, in this interval, okay, Okay, where was the interval? Okay, in this interval, yes, that is in the first quadrant, sin x is always positive. Agree from the ASTC rule. Here, all the functions are positive, right? All the trigonometric functions in the first quadrant. So now, since sin x is positive, let me divide this by sin x. Okay. So yes, we are dividing this with sin x. Okay. Divide by sin x. Yes, so what would I get? I would get 1 less than x divided by sin x. Okay. This is less than sin x divided by cos x. Can I write tan x as sin x divided by cos x? Yes. So what are we dividing the whole inequality by? 1 divided by sin x, right? So this sin x and sin x gets cancelled. So I can write it as x divided by sin x. This is less than 1 divided by cos x. Now let me take the reciprocal. Yes, what would I get if I take reciprocal? 1 would remain as 1. And since we are taking reciprocal, the sign would change. Yes, we would get greater simple sign. So yes, I would get sin x divided by x. This is greater than cos x. Or I can write in the other way. That is cos x is less than sin x divided by x. And this is less than 1. Okay. So we've arrived at this. Yes. Hence the proof. Okay. So yes, what did we study in this class? We studied about sandwich theorem. It states that if f, g, h are real functions such that f of x is less than g of x less than h of x. Yes, we drew that in a graph. Yes, f of x, g of x, h of x. Yes, so g of x is in between h of x and f of x, right? They are saying the domain is same for all the three functions. Yes, then for some real number a, if the limit x tending to a, f of x is equal to L, that is a limit. This is equal to limit x tending to a, h of x, then limit x tending to a, g of x is equal to L. Okay. So how did we prove? So since this is a geometrical proof, we wrote an inequality. We took an inequality involving trigonometric functions. Okay, that is cos x less than sin x divided by x less than 1. So basically we had to prove this. Yes, I took x and y axis. Okay, so the trigonometric function that we took, that was for 0 less than mod x less than pi by 2. Yes, so if I replace in sin x and cos x, x with minus x, we can see that sine of minus x is minus sin x because it is an odd function. Yes, cos of minus x is an even function. So cos of minus x, we would get it as cos x itself. So over here, if I replace x with minus x, I would get cos x less than the same thing, sin x divided by x less than 1. So since we are getting the same thing after replacing x with minus x, I can remove the mod. Yes. And what is this inequality? Where does this lie? This is basically the first quadrant. Okay. So in that first quadrant, I took a point C. I joined it with O, yes, from the origin. And then I took a tangent from the A, yes. And then I drew two perpendicular lines that are perpendicular to basically the x-axis. Okay. So from this setup, it is clear that the area of the triangle OAC is less than the area of this sector OAC, which is this sector is also less than the triangle OAB. Yes? So what is the formula for area of a triangle? It is half base into height. Yes? So after using the formulas, we again took the two right angled triangles. We found sin x and tan x. Yes? And then we substituted them, and after some simplifications, we arrived at cos x less than sin x by x less than 1 for, yes, I can write for 0 less than x less than pi by 2. Yes, that is it for today. Thank you.